3/4 of our planet is covered in water, yet most of us drastically underestimate exactly how deep that water goes. This model shows what happens if we ran a massive thought experiment. Imagine shaving off all the land from the tops of every continent and island in the world. If you pushed all of that rock into the ocean's deepest points to level things out, the entire globe would be covered in an ocean 2 miles deep. Before we start going down, let's establish a sense of scale. Here is the size of an average human. Next to that, an elephant. And here is the Nock Nevis, the largest ship ever built. Keep these in mind as we start heading underwater. The first milestone is just 40 meters below the surface. This is the maximum depth allowed for recreational scuba diving. Dropping down to 93 meters, we find the wreck of the Lusitania. This is interesting because the ship is 240 meters long. It sank in water so shallow that if the ship were standing upright on its bow, the back half would be sticking completely out of the water. Pushing just slightly deeper to 100 meters, diving becomes seriously fatal. Without extreme care, the pressure here causes decompression sickness. Our biology traps us in the absolute thinnest top layer of the sea. Going any deeper requires specialized mechanics or entirely different evolutionary biology. Moving past the limits of human freediving and specialized scuba records, we arrive at 443 meters. This is the exact height of the Empire State Building, fully submerged underwater. At 500 meters, we hit a hard biological and mechanical ceiling. This is the maximum dive depth for the planet's largest animal, the blue whale, as well as the limit for the U.S. Seawolf-class nuclear submarine. Dropping to 535 meters brings us to the maximum dive depth of emperor penguins.
The water pressure at this level is roughly equivalent to the force of a polar bear standing on a quarter. Further down, at 830 meters, we reach a depth that would entirely swallow the tallest building in the world, the Burj Khalifa in Dubai. Once we cross the 1,000-meter mark, light from the surface absolutely cannot reach any further. The rest of the ocean below is shrouded in permanent, absolute darkness. Down here, the total absence of light and compounding pressure renders standard surface world engineering and visual comparisons useless. The water pressure below 1,000 meters is roughly the same as standing on the surface of the planet Venus. Without heavy protection, you would die very quickly. Yet life persists. This is the domain of the giant squid, and at 1,280 meters, we find the maximum depth reached by the leatherback sea turtle. To give you a final terrestrial marker, dropping to 1,828 meters is equivalent to standing at the deepest part of the Grand Canyon. By 2,000 meters, the biology gets highly specialized. Take the black dragonfish, a carnivorous beast equipped with a stomach that doesn't allow light to emit through it. It consumes bioluminescent prey and traps their light inside its gut, preventing larger predators from spotting a glowing meal in the dark. At 2,250 meters, the total darkness hosts violent clashes. Sperm whales hunt down the colossal squid, a creature growing up to 14 meters long and weighing 750 kilograms, with eyes the size of dinner plates and razor-sharp sickles in its tentacles. The environmental barriers of darkness and pressure have forced the biology here to evolve into completely alien, predatory forms to survive. Accelerating the descent, we reach 3,800 meters. This is the final resting place of the RMS Titanic. Past that, at 4,000 meters, we enter the abyssal zone, where the pressure sits at 11,000 pounds per square inch. Just beyond this, at 4,267 meters, we hit the average depth of the global ocean floor. But the floor isn't completely flat. We continue falling down to 4,791 meters, past the wreckage of the World War II battleship, the Bismarck. This chart visualizes the physics at 6,000 meters down, the start of the Hadal zone. The water pressure here is 1,100 times what you feel on the surface, the equivalent of a single person carrying the weight of 50 Boeing 747 jumbo jets. Dropping to 6,500 meters, we find the absolute operational limit of the DSV Alvin, the research submarine that helped locate the Titanic. At 8,848 meters below the surface, the depth matches the exact height of Mount Everest, were you to flip the mountain upside down.
Exploring this deep requires vehicles capable of withstanding forces that would instantly obliterate almost any natural or man-made object on the surface. Arriving at 10,898 meters brings us to the depth reached by director James Cameron during his solo dive in the Deep-Sea Challenger in 2012. But the absolute deepest human dive in history happened decades earlier, in 1960, when Don Walsh and Jacques Piccard reached 10,916 meters in the Trieste. The peril of that expedition was severe. It took them 5 hours to descend, and they fled after just 20 minutes because the pressure cracked a window. To put this journey into perspective, imagine looking out the window of a commercial airliner. The vertical drop from that plane to the ground below is the exact distance we just traveled underwater. We finally hit bottom at 10,994 meters. This is the Challenger Deep, the deepest known point of the ocean. This is only the known bottom. Massive trenches still hide in the dark. The Sirena Deep, which plunges to 10,732 meters, wasn't even discovered until 1997. This map shows the current state of our geographic knowledge. We have accurately mapped a mere 5% of the global ocean floor. The remaining 95% is currently a mystery. The greatest mystery on Earth is right beneath us. We know more about the surface of the moon than our own ocean floor, leaving the likely possibility that even deeper abysses are waiting to be found.